Hello everyone. In previous video I have discussed about the basic concepts involved in optoelectronic devices. In this video I am going to discuss about the topic of polarization and the concept behind it. Polarization. Whenever we are transmitting an electromagnetic signal in an open space environment, it has the electric field vector in a specific plane. So that wave was said to be a plane polarized. Any real beam of light which comprises of many individual signals and in general the planes of vibration of their electric field will be oriented randomly. Such beam of light is unpolarized. Altogether, the resultant electric field vector changes according to the orientation in that line randomly. It is possible only when a beam of lights are characterized by the highly oriented electric field, and such lights are referred to be an polarized wave. The simplest form of polarization is a plane polarized wave, which is similar to the sine wave. The light can be polarized in the many ways. Here we consider two concepts, one is by reflection and another one is by absorption. When an unpolarized light is incident on a metal surface, we could able to find the light with its polarization vector which is perpendicular to the plane of incident wave. Preferably it is reflected in comparison with light polarized parallel to the plane of incidence. Here, the diagram shows the concept of reflection and the absorption of the light whenever it incident on a surface. The parallel component, the reflection is 0 at a specific value of incident theta, that is equal to theta b. So here the angle of incident, which is called as the Brewster's angle, all the parallel components is transmitter. It is found also that for incident or any Brewster's angle, the angle of reflection and the refraction are perpendicular to one another, which is illustrated in this figure B. So according to the Snell's law, for the angle of reflection at interface between the two media of refractive indexes N1 and N2, we can write angle of incidence and the reflection, that is a Brewster's angle, that is equal to 90 degree. So we consider two mediums, two refractive index mediums N1 and N2. So we write the equation as N1 sine theta b, that is equal to N2 sine theta r, which means I am rearranging the above equation as 90 degree minus theta b for the angle of reflection. After substituting that, I will get N2 is equal to cos theta b. So according to the Brewster's angle, I am rearranging the above equation as N2 by N1, that is equal to sin theta by cos theta. We know sin by cos is equal to tan. After applying that, tan theta is equal to N2 by N1. I am bringing the tan to the right hand side. It automatically become tan inverse. So the Brewster's angle is equal to tan inverse of refractive medium N2 divided by the N1. So the next one is about Malu's law. According to this law, when completely plane polarized light is incident on the analyzer and it analyze the signal, the intensity I of the light get transmitted by the analyzer, which is directly proportional to the square of the cosine of angle between the transmission axis of the analyzer and the polarizer. So I am here writing the equation based upon these law that intensity of the light is directly proportional to the square of the cosine signal. Here this angle is taken between the transmission axis of the polarizer and the analyzer. Fine. Initially, I am giving here an unpolarized light which may be randomly oriented in all the directions, which may be transmitted in different ways. So, that light is given to an transmission axis, that means a polarizer. It is polarized to travel in a plane wave that is passing through the that is given to the analyzer will analyze the intensity of that signal, and that can be transmitted to the photodiodes. So here the equation clearly says that it directly proportional to only the square of the angle between the analyzer and the polarizer concept. Here, the two polarides are used, whose transmission direction makes an angle with each other. So, in order to remove the proportionality, I have written that is I naught, where I naught is the intensity of that particular light. Based upon this angle, I am going to determine the intensity of the light I. So when theta is equal to 0 or 180 degree, automatically intensity I, that is equal to I naught. So the intensity of the transmitter light by the analyzer is maximum when the transmission axis of the analyzer and the polarization are parallel to each other. When theta is equal to 90 degree or 360, when it is 90, automatically I is equal to 0, then automatically the intensity of the light between that which is transmitted by the analyzer is minimum when the transmission axis of the analyzer and the polarizer are perpendicular to each other. So this is about the basic concept of polarization and the Malthus law. Many topics I will discuss in the upcoming videos. Thank you all.